Hi there and welcome. My name is Rebecca Weaver and we're going to divide monomials today. We'll need to look at our exponents again, so let's look at them. Now let's remember that multiplication property that we did the other day. A to the m times a to the n. Remember that when we multiply with like bases, we add exponents. That power property, remember that one that we did? When we have a power raised to a power, we multiply exponents. Well, what happens with division? We didn't look at division. Well, if we add some x to the fifth over x squared, then it's the same as writing x times x times x times x all over x times x. All right, so what happens is that two of those x's on top cancel with two of the x's on bottom, leaving me with three x's, or x to the third. I don't want to write all of that out every single time I do this, so let's kind of come up with a general rule of what's going on. When we are dividing with like bases, we need to subtract exponents, because x to the fifth over x squared is the same as having 5x's on top and 2x's on bottom, them canceling out, meaning 5 minus 2, and getting x to the third. Okay, when dividing with like bases, subtract exponents. Well, there's an interesting situation that occurs because of this. Because if I have x squared over x to the fifth, meaning I had 2x's on top and 5 on the bottom, those 2 on the top would cancel with 2 on the bottom, and I would end up with 1 over x to the third. That's because I have more x's on the bottom than I do on the top. So when they cancel out, I end up with more x's on the bottom. Okay? So when we're dividing with like bases, we subtract exponents. So what does that look like when I just do that subtraction? Well, I would write that as x to the 2 minus 5, which ends up as x to the negative 3. So what a negative 3 exponent means, it just means that they're in the bottom. So negative exponents don't have anything at all to do with something being negative. What it means is that it belongs in the denominator. So negative exponents mean that the denominator had more x's. I call that bottom heavy. It's heavier in the bottom with x's. Now the negative exponent means that the x's are in the bottom of the fraction. Let's look at the quotient property for exponents. We have a to the m over a to the n equals a to the m minus n. That is, we divide with like bases, we need to subtract exponents. And we need to know that this is for a's real number, he can't be 0, and m and n are whole numbers. Remember to rewrite those negative exponents as positive by moving them to the denominator. A to the second over a to the eighth. We can look at this and see that the denominator is heavier with the a's. I should end up with more a's in the denominator. So I don't want to just go blindly solving the problem and not realize where those a's belong. Look at that as 2 a's in the top, 8 in the bottom. So when I do a to the 2 minus 8 and I get a to the negative 6, note that that's 1 over a to the 6th. Now, whenever you're working these, also note that your answers will need to have positive exponents. For some reason, mathematicians don't like you to leave it with negative exponents. So be sure that move it to the appropriate spot. What about the zero property for exponents? When I have a to the m over a to the m, that's going to be a to the m minus m, or a to the 0. So when we divide a number by itself, we know that the result is 1. What that really is just something to the 0 power. This is if a is a real number and is not 0, and m and n are whole numbers, or just m in this case. So a number with a 0 exponent is the same as a number just divided by itself. So if I have a squared over a squared, I can look at that and tell you the answer is 1 because the a squareds cancel with each other. It's the same as 5 over 5 or 2 over 2. But just going through the motions to make sure that we get the same thing, this would be a to the 2 minus 2, which is a to the 0, which equals 1. So for the power property of exponents, if a is a real number and m's a whole number, then you need to note that this fraction, a over b raised to m, can just be written as a to the m over b to the m. That is, when we raise a fraction to a power, we raise both the denominator and the numerator to that power. An example of this would be 2 over 3 raised to the third. That's just 2/3 times 2/3 times 2/3, or you could have just said 2 to the third, which is 8, over 3 to the third, which is 27. All right, let's play. We have big old whopping thing. Let's see here. We have negative 2 m to the fourth, all raised to the third, times m squared raised to the second, all over m to the third raised to the fifth. Well, we're going to eat this just like we do a pie, one bite at a time. So let's just deal with the exponents on each one first. I'm going to do negative 2m to the fourth raised to the third. So that's going to end up being negative 2 times negative 2 times negative 2. So that's negative 8. My m is now to the 12th. The next little piece was m squared raised to the second. That's m to the fourth. My next piece is that denominator, m to the third raised to the fifth. So that's m to the 15th. So let's just take care of the numerator first. And we'll just say that that numerator is negative 8m to the 16th because I added the 12 and the 4. Then I have 16m's over 15m's, which is m to the first. I don't like to write m to the first, so I'm just going to write it as negative 8m. My next example is negative 72, a to the 7th, b to the 3rd, all over 8, a to the 12th, b to the 4th. Let's note where our a's and b's are. Notice I have 7 a's in the numerator, and I have 12 a's in the denominator. This answer is going to have more a's in the denominator. B to the 3rd over b to the 4th. I'm going to end up with a b in the denominator. 72, negative 72 over 8, that's going to be negative 9. So I'm going to have negative 9, a to the 7 minus 12, b to the 3 minus 4. That's going to give me negative 9, a to the negative 5, b to the minus 1. We can't write our exponents as negative, so we need to just put them where they belong. This will yield negative 9 over a to the 5th, b to the 1st, and I don't write that one. Let's look at one that's crazy looking. Wow, okay. X to the 4th y, all raised to the 2nd, times 4xy, all over 12x cubed raised to the 2nd, times xy cubed, all raised to the 3rd. Okay, one bite at a time. Let's do that first piece. X to the 4th y squared is going to be 4 times 2 is 8, and 2y's is y squared. That next piece, just write him down. Then we need our fraction bar. Let's do the 12x cubed squared. 12 squared is 144. X cubed raised to the 2nd is x to the 6th. Then the next piece is x cubed, y to the 9th. I'm multiplying exponents there. Now, I'm going to take care of the numerator, and I'll take care of the denominator. If I take care of just the numerator, I take care of that 4. And then count up my x's. I have 8 there and 1, so that's going to be x to the 9th. I have 2 y's here, 1 here. That's going to be y to the 3rd. 144, just write him down. X to the 6th times x to the 3rd, well, that's x to the 9th. And then y to the 9th. All right, so 4 and 144. Those things cancel. Get a 1 there. Get a 26 there. Those x to the 9ths, they're gone. They just cancel themselves out. So I have 3 y's on top, 9 on the bottom. 1 over 26y to the 6th. And that would be your answer. If you have any questions, be sure and email me, rweaver10@alaska.edu. Have a fantastic day. Bye now.